different types of models can be compared. The two models we're going to look at are linear and quadratic. We are already familiar with linear, quadratic, and even exponential functions, so let's just recap what we already know. A linear function has the equation y equals mx plus b, where a quadratic function has the equation y equals ax squared plus bx plus c. We know it's a linear function because the graph creates a straight line, where a quadratic function is created by a parabola, looking like a U-shape or an upside-down U-shaped curve. I'm now going to show you how to use your graphing calculator to identify the type of equation. We will also look at patterns within the table. We can even go ahead and graph each of our functions. Take a look at this first table. Look at your x values. They're going up by 2, 1, 2, and 2, whereas your y values are going up by 4, 2, 4, and 4. Remember, you can identify whether a function is linear if it has a constant slope. The slope in this case would be 2. Let's show how to look at this on a graphing calculator. You can input a table into your graphing calculator following these steps. After you've turned your calculator on, you're going to click Stat and then Enter. Your calculator screen should have an L1, L2, and L3 at the top of the screen. Into L1, you're going to put your x values. And into L2, you're going to put your y values. Since this table had a slope, I'm going to assume that it's linear. To get the equation of the line, you will follow the following steps. Hit Stat again, go over to the column that says Calc, and identify number 4, LinReg, which stands for linear regression. Then you will hit Enter. On your screen is the equation. Notice you have y equals ax plus b, also known as slope-intercept, often seen as y equals mx plus b. Your a value is 2 and your b value is negative 3. Now take a look at the table for number 2. Again, notice the change in the y's and change in the x's. You can clearly say that this table does not have a slope, as the change in the x's stay the same, but the changes in the y's are not. What you will do now is you will find the pattern by continuing. Is there a way to get from -3 to -1, from -1 to +1, and from 1 to +3? Notice also your original y values are also symmetrical. The y value of -2 would be in the center, then -1s surround it, and then +2s. If you look at the differences again, the pattern still stays symmetrical. The difference from -3 to -1 is +2, from -1 to +1 is 4, and from +1 to +3 is 2. When your patterns remain symmetrical, you have a quadratic equation. Now we're going to input this into our calculator. Remember, to get into this screen, you need to hit Stat, Enter. Clear out the data that's already there so you can put new data in. Now that you have your data in order to get your equation, follow these steps. Hit Stat, go back over to Calc. This time you were looking for number 5, which says QuadReg, which is quadratic regression. Once you hit 5, you will hit Enter. Notice your equation is now given to you. Y equals ax squared plus bx plus c, which is the format for a quadratic equation. Your a value is 1, your b value is 2, and your c value is -1. There are two examples for writing equations, given a table. You can go ahead and graph these as well. For the quadratic graph, I'm going to have to remove my work to have the space.